Good morning, everybody. How's it going? I'm going to just sit here and riff for a second because I forgot to plug in my clicker. So just give me a second to do that. How's everybody enjoying the conference? Yes? That was weak. Come on. How's everybody enjoying the conference? Thank you very much. All right. All right, excellent. And this is working. Good. That was successful. Here. Okay. Firefox dev users, anybody else? I see a couple hands. We're the cool kids. Is this mic okay? It feels a little bit echoey. Is it okay in the back? All right, excellent. Welcome to Building for Utopia. I'm Gemma Anible. I'm a software engineer. I work for WonderProxy, which is a global proxy company. We help people test their localization on their websites. If you need to localize your website, come talk to me afterwards because I can help you. I've got a long and not so glorious history of software engineering background, and I have a master's degree in software engineering as of last year. So that's me, and that's where I'm coming from. My husband and I just moved to Norway. He got a job at a college. He's a professor, so we picked up and moved to Norway. And we moved from Albuquerque, this is what Albuquerque looks like, and that is what Norway looks like. So it's a bit of a switch, and everything is new. Everything is new in Norway. We don't have a car. We were warned ahead of time. Don't have a car in Norway. It's much too expensive. The insurance is expensive. The vehicles are expensive. Everything's expensive. Don't have a car. So we're walking everywhere and biking and taking the train, and that's really fun. We don't speak the language. I'm not Norwegian. My husband is not Norwegian. We don't have any Norwegian family. So we're very slowly learning Norwegian and spending a lot of time apologizing to native Norwegians for not speaking their language. They are all very accommodating because they all speak English, which is great, but we still feel bad about it. The daylight hours, this is another very new thing in Norway. The daylight hours are getting completely wild. Bergen is, I apologize, Derek, I can't actually pronounce the name of the town. Bergen, Norway, is on the western side, western coast, and it's at the same latitude as Anchorage, Alaska. So right now, it's getting bright in the morning at around 3:30, and it's not really dark until about midnight. So that's a new experience. We have a new stove. We have an apartment, and this is our new stove. Isn't it great? It's a stove, you guys. It's electric. Everything in Norway is electric, not gas. When we first moved, I asked our landlord how to set up gas utilities, and he was like, "We don't do that here. What are you talking about?" Everything's electric, so this is an electric stove, and yeah, that's our stove. Very exciting. So when we moved, we had to do all these registrations and things with the government and with the tax administration. We had to go in person to places and fill out forms and get all the flyers and go back again and fill out more forms and figure out employment and postal service and all these different things. So we were spending a lot of time going in person to all these government offices. And every time we went, the officials would load us up with flyers to bring home. Welcome to Norway flyers, working in Norway flyers, things to do in Norway flyers, how to be safe in Norway flyers. And one of them, Benjamin and I, my husband, Benjamin and I, laughed hysterically at because it was an entire flyer about the dangers of cooking at night and using your stove at night. And we thought, okay, well, it's an electric stove. Everything is electric. Maybe there's some sort of weird electrical grid problem at night. Maybe that would, the power would fluctuate and the stove would blow up. I don't know. We were really confused. And turns out, no. Stove fires most often happen at night. You come home from a night out, it's 1 or 2 in the morning, you may not be completely sober. You decide you're a little hungry, you cook yourself some food, and you go to bed without turning off the stove, and you burn down your house and kill yourself. So apparently this is a big enough problem in Norway to warrant an entire flyer from the government to immigrants, which is what we are, incidentally. So Benjamin and I thought this was hysterical. We were just, how could so many people be so careless that this is the result? Well, you may guess where this is going at this point. About a month after we moved to Norway, Benjamin took off. He had some sort of educational something or other in Spain where there was a beach and sun, and I was in Norway with rain and cloudiness, and I wasn't at all bitter about this. So I was alone in Norway for 3 weeks after we moved there with my 2 dogs. And I lasted about a week before I left the stove on overnight. I work out of the house. I work for Wonder Proxy remotely now. So I'd finished my day. I don't remember exactly how it happened. I was probably, playing video games because I do that, or watching Netflix because I do that too. It got to be around 10 or 11. I decided I was hungry. Went and made myself some scrambled eggs because that's my go-to at night when I'm hungry. Took the pan off the stove, thank goodness, and did not turn the stove off. Went to bed. Woke up the next morning. Went into the kitchen to take care of the dogs, and it was like 90 degrees in there, with a thick layer of condensation over every single glass surface. So just water, like rivulets of water dripping down everything. It was scary. It was scary, but I was also very thankful that nothing had actually happened. So I don't like to think of myself as a stupid person, personally. I think that probably goes for everyone. You don't like to think of yourself as stupid, but I'm kind of the classic, child is identified as gifted and then incorporates innate intelligence into the core of their identity and then turns into an adult that's terrified of failure because if you fail, then you're not smart and that's who you are. I'm that classic case, that's me. So I really don't like to think of myself as stupid, and yet I almost burned down my house and killed myself, my dogs, and my landlord. Was I careless? Yes. Clearly. Obviously. I did not exercise the correct level of care to safely operate this stove. 100% that's what happened. So, but let's just look at how much care you need to operate this stove. So here's sort of a close-up of the controls. This is gonna look familiar to you guys because it's a stove. So, left to right, this is this burner right here. So leftmost burner is the leftmost dial is the front left burner, and it goes around clockwise from there. And then oven controls on this side. These are 2 little lights. This is for the burner. This is for the oven. This is pretty standard. There's some like straight and squiggly lines on this dial. I don't actually know what those are. They seem to indicate heat of some kind. I'm not really sure. I'd need to look it up. But so that's a stove, and it's pretty normal. So here's the stove top. This is just a top down from the stove. Which burner is on? Anybody? You guys all fail. Which burner? None of the burners are on. Which burner is warm? Doesn't have to be on to be warm. You might have just cooked something, taken something off. So this interface right here, this tells me nothing about the current status of any of the burners, on or off. It tells me nothing about the current temperature of any of the burners, on or off. So this is problematic, but it's not really fair, right? Because you got to use the controls. That gives you the information. All right, so here's one with the controls. Who saw that a burner was on? Who saw which burner was on? Are you sure? That's not on. It's like halfway between off and 1. It's off. This is on. Yes, really. I promise. So we'll try another one. That was kind of cheap. So here's this one. Who saw that the oven was on? The temperature is on, like the temperature specification, but that doesn't actually turn on the oven. This burner is on, but it's vertical, so it's hard to see. This stove, most stoves, this is like a lot of stoves. This stove is built for Utopia. This is a stove that's built for people who never make mistakes, who are never in a rush, never hurrying, who are never careless, who always inspect all of the dials very carefully before they leave the room, who always check all the burners before they put a pan on one of them. This is for people who never make mistakes. This is for Utopian people. I'm not one of those people, clearly. Whose blood pressure just went up? Yeah, I see some hands. So stovetops are not the only everyday object that sort of were built for utopian people. And this is one of my favorite examples. This door is lying to you. So the user interface here is the handle. It's the handles. It's not the labels. The labels are incidental. The user interface is the handle. It's exactly the same in both cases. And the shape of this handle begs you to grab it and pull. That is what the handle wants you to do. And yet, if you try to do that on this door, you're just going to stand there like a derp and go, oh, ugh. I have this experience with doors a lot because I don't read signs, because I'm not a utopian person. So these are pretty classic examples of user interface bugs, I guess. User interfaces that lie to the user, like this, or that don't give the user enough information, like the stove. But the tendency to build for utopia doesn't just exist in physical objects. It exists any time you've got a system or process or anything that involves human beings at any point. We're always going to have the tendency to build for perfect people who don't make mistakes. Who really likes the Git command line? Yes! Thank you so much, you're my people. I also love the Git command line. I know it's infamous for having a sort of sketchy interface experience. But I love it. And I recommend beautiful GUIs to people for Git if they're learning. But I use the command line almost exclusively. Who uses this little upstream thing? Anybody recognize that? A couple of people. All right, so this is a really cool shortcut in Git. We're just going to take a little detour to talk about Git for a sec, because it's one of my favorite subjects. That at curly brace, upstream, close curly brace, is a shortcut for whatever branch master is tracking. So normally that's going to be, origin master. So this whole specification here, master upstream, is referencing the origin master branch. And that's really cool because it lets you do, it lets you script things, lets you have Git aliases that are really convenient because you can just reference the upstream without necessarily knowing what the upstream is. So it's cool. This is a shortcut for the shortcut. You can just use U, the letter U, which is lovely, and that's what I use most of the time. Although what I really use is this. Because you have to hold down Shift to get the @ sign and the curly brace, right? And I'm bad at lifting my pinky key off, or my pinky finger off the Shift key quickly enough. So then I do a capital U. And then I backspace twice because I'm like, I did it wrong again, instead of backspacing once. And then I have to redo the curly brace and make sure I do a lowercase u and then close curly brace. This is an interface, like a lot of command line Git, that's built for utopian people who always lift their pinky fingers at the right time. This is a great shortcut that I make longer because I can't type properly. So that's one software example. Another software example. Vim! Who saw the Stack Overflow post from 2 days ago? Yes. OK, so if you haven't seen it, Stack Overflow blog did a post on one of their most popular questions. And if you're anybody not familiar with Stack Overflow? OK, good. I won't explain what that is then. So one of their most popular questions is, how do I exit Vim? It's got over 1 million views at this point. It's got, the question itself has over 1,000 upvotes. It's almost a sysadmin, like a newbie sysadmin rite of passage. You accidentally get stuck in Vim because something dumps you in there. Some other tool will have Vim as the default because it's so popular and so ubiquitous. And you'll end up in there and you'll go, OK, this looks like a text editor. All right, well, I guess I'll start typing. And then you don't know what's happening. And then there's stuff moving all over the place, and you just copied something and it ended up over here, and now there's random letters, and you're like, oh my goodness, how do I undo any of these changes? How do I get out of here? And Vim doesn't tell you. Vim doesn't help you figure this out. Vim is built for people who know how to use Vim. Vim is built for Utopia. It's built for perfect people who already know to hit, escape, Q, bang, to exit without saving anything. It's designed for experts. It's designed for Utopia. And Vim is a great example of where that's not necessarily a bad thing, but it is an example. So that's Git, that's Vim. Those are both software, or pieces of software. And everything I've talked about so far is essentially a user interface. I'm not a designer. I'm not a user experience expert. I'm not a UI expert. I don't have any advanced training in any of those things. It's just user interfaces are kind of the low-hanging fruit as far as identifying these sorts of assumptions. But they're not the only fruit. Who knows where I'm going next? Oh my goodness, okay. Aha, I saw a couple hands, all right. This is a graphical representation of what's called the waterfall software development methodology. So this is a way of building software, organizing a team into building software that sort of, it came out of manufacturing processes where change is extremely expensive. Because if you're building a widget or a doodad or a crockpot or whatever, you can't, and you've got your objects, you've got your physical, tangible objects. You can't push an update to your crockpot and say, make this ceramic bowl, 2 inches wider. So change is very, very expensive in manufacturing. And manufacturing processes are designed to reduce change, limit the change. And waterfall came out of that environment, sort of rose to prominence in the late 20th century. And it works like this. So first, you have the requirements phase. It starts, and you figure out everything your software is supposed to do, but not just what it's supposed to do, also any security requirements, any environment requirements, technical requirements, performance requirements. You figure all of this stuff out ahead of time, right up front. And when you do it in conversation with your customer, generally speaking. And when you're done, the requirements are locked. You get this requirements document, that's sort of the output of this phase. And it's locked. That's the end of that phase, and you move directly to design. If you want to change anything, who's worked with change review boards? Yeah, I'm hearing giggles and seeing hands. It's not fun. It can take weeks or months to get stuff changed after the fact, after you get out of this phase. So then you move into the design phase, and now you're sort of defining the structure for your software that's going to meet the requirements that you already figured out. And this gets extremely detailed. This isn't just overall like, oh, I think we should use this kind of object over here, and maybe that, and then we should do this. One of my former bosses once told me that in his ideal world, an implementation plan, which is also one of the outputs of this design phase, an implementation plan should be so detailed that any software engineer with familiarity with the tech stack, so like if you're working in PHP, you get a PHP engineer. Any engineer could take the implementation plan and, knowing nothing about the rest of the project, code the software to the requirements based on the implementation plan. That's his ideal, and that's the level of detail we're talking about in this design phase. Which, I don't know if you guys are like developers or something, but it's not how it works. Doesn't do that. And the rest of the phases are pretty self-explanatory. So implementation, you're taking the output from the design phase, which is a design document and implementation plans, and you're writing the software to the design. After you've built the software, you start doing verification. You start testing after it's built. Anybody else twitching right now? Yeah, okay. Start testing, you give it to the customer now that it's built, and you make sure they're still happy with it. And then you deploy it, and then you're in maintenance mode. And the reason this is called waterfall is because if you follow the arrows down, it looks like a waterfall, right? Water babbling over, stones in the woods. And the arrows don't go backwards. There's no arrows going up. So that's waterfall. Software development doesn't actually work like this in the real world. None of this. It doesn't work like any of this in the real world. Developers do not have enough information at the beginning of a process to write a complete spec of the requirements. Your customers don't have enough information at the beginning of the process to write a complete spec. They don't even know for sure what they want. How many people have written something to spec for a customer and given it to them and they say, oh, actually, we're kind of thinking maybe we want this instead. That happens to everyone because that's how software works. That's the nature of software. We are engaged in knowledge work. We're engaged in creative work. And it's very changeable. And this is not a process that models it well. This is like if you wanted to build a model airplane of a Boeing 747 and you built a model Ford Mustang. Like that's the comparison for this. Waterfall software development is software development for Utopia. It's software development for people who have all of the information right up front and who never make mistakes and who don't need to test things. You can just do all these phases very cleanly and then ship a product that the customer loves and you're done. That's Utopia. That's what Waterfalls is for. Utopian expectations also apply when we're actually writing code, like at a much lower level than the software development methodology that you choose, whether that's Waterfall or something else. I can remember I worked for a company in upstate New York 10 or so years ago. I was a software engineer, and at that time, automated testing was still a little bit edgy where I was. Silicon Valley had already embraced it. Silicon Valley was like, this is the best thing ever, it's amazing, we're all doing this. But I was in upstate New York writing NCC, and we did things differently there. So I started reading about it, and I did a bunch of research, and I saw some of the really famous studies from Microsoft and IBM. And I was like, man, this seems to improve code quality, and it seems to decrease the defect density, the number of defects per line of code. We should maybe think about doing this in my company, in my department. So I started trying to sell my department on automated testing. This is a department that had been doing software engineering for 20 years before I got there, and they would keep doing it for 100 years after. I was very much an interloper in this department. And I can remember talking to my department head about automated testing and how I thought this was going to really help. And he looked at me almost in confusion. You don't need to write tests. Just write correct code. Duh. I mean, he didn't say duh, but that was the sentiment. Like, obviously, you don't need to write tests. Just don't write crappy code, and you're fine. You don't need tests. You don't need all that extra overhead at the beginning of the process. Just write correct code. Don't make mistakes. Just never make mistakes in your code. Just never, forget edge cases when you refactor. Just never leave behind functionality when you add new functionality. Just write correct code. I've heard very similar attitudes about the necessity of code comments. Things like if you need comments in your code, you need to rewrite your code so it's readable enough that it doesn't need comments. Who's in that camp? So there are things about that sentiment that I love, and the biggest thing is that readability isn't really important, and I agree with that. We should be writing readable code. It's going to improve maintenance and evolution. It's going to make just everything much, much easier later on. That said, it takes a decent amount of hubris to think that the code you write is so clean and so elegant that anybody, any developer of any experience level, can read it without help. You're making some assumptions about your own code there. You're making some assumptions about how great you are. And maybe you are that great, but you're probably not that great all the time. I'm definitely not. I know that I have written, I always strive to write clean and elegant code that's readable, that my coworkers can look at and understand and be able to modify. I always do that. I try. And then I'll go back to the same code 2 months later and look at it and be like, what was I thinking? Why didn't I put comments in this? I have no idea why I'm putting this loop here instead of over here, and why I'm doing this nonsense with a temper. What is this? That's my experience with attempting to write clean and readable code that doesn't need code comments. It also makes, that sentiment also makes some utopian assumptions, not just about yourself, but about your readers. Are your readers, is everybody on your team like a senior dev with lots of experience reading code? Because that's an acquired skill. That's not something you can just sort of step into and know how to do really well. And if you're a newer developer, you might not even you may not have the background to even understand what's going on. And I'm not talking about comments like, you know, you've got a line that says y equals x plus 1 and a comment that says add 1 to x. Like that's not a helpful comment to anyone. But if the comment says increase volume, that's a helpful comment. That tells me, you know, why are we doing what we're doing in this code section? And that's useful. Yeah. So how do we stop doing this? How do we stop assuming utopia in the things we build and the processes that we implement? One of the big things, and this isn't always possible, but a lot of times it is, use your software. Use it yourself. You're not always going to be the target market for your own software. I'm not for a lot of the software I write, but I can use it to some extent. And you can tell where stuff starts to feel awkward, where maybe there's 14 steps in between A and B, and there really should be fewer than 14. The Git example that I used earlier with the lowercase u, as of Git version 2.13, that's no longer case sensitive, right? And the reason that is because one of the Git developers had had enough. He, in his commit for the code that changed this, he literally said, "I'm scratching my own itch here. This is something that has bugged me, and I'm fixing it." He used his software, and he saw that there was no reason to expect excellence here. There was no reason to assume utopia in this command. Just let it be capital U, and that's fine. For the cases when you can't always use your software to that extent, like obviously a Git developer is going to use Git, of course. If you're writing software that is completely outside your comfort zone, as far as using it, get serious about feedback from your users. And I'm not just talking about aggressively pursuing comments from your users, shooting them emails and begging them to tell you things. At WonderProxy, and I'm sure a lot of you folks too, at WonderProxy we're working on a new project called Observio. It's a monitoring system. And we've got logging built in, so we're tracking everything any user does on our system. We're tracking when they create new monitors, we're tracking when they delete them, we're tracking when they run ad hoc tests, we're tracking, which pages they're visiting and how often and in what sequence. So we can see behavior that looks strange. Like maybe they created and deleted a monitor 4 times in a row in the space of a minute or two. Maybe there's something wrong. Maybe something was awkward. Maybe they're trying to edit something and they couldn't edit it. So we can reach out to them about that specific instance and say, hey, we saw this was going on. Can you tell us about that? Was the software not meeting your expectations? Was it doing something you didn't want it to do? Was there something it wasn't doing that you wanted it to do? Let us know. That's something we can do. The other thing you can do is find some experts. Not me, but there are design experts. There are people who are trained in user interfaces. Design experts, user experience experts, user interface experts. Find these people, hire them, train them, and then use them. Don't treat it as optional. Don't treat it as like, oh yeah, we got to make sure the design guy does a once-over on this. This is critical because when your software assumes that your users are perfect, it's just going to make them mad. It's just going to make them frustrated and annoyed, and they're going to either be mad at you or mad at themselves for not knowing how to do stuff. And you don't want your users to have that kind of experience with your software. That's no good for anybody. So that's software. How do we get Utopia out of our processes? How do we build software in a way that recognizes we're human beings and not utopian perfection beings? So if you're doing sprints, if you're doing Scrum and you're doing sprints, at the end of every sprint, you have a retrospective, and you kind of talk about how this sprint went and how everybody felt about it and what they would do differently. And a lot of times that turns it, just from my own experience, maybe this is different for you folks. From my own experience, a lot of times this turns into, man, it was really annoying that marketing didn't get us those assets in time, and this piece of code was really hard, and it's not necessarily about the process, it's more about specifically what happened in that sprint. And that's great. That's an important conversation to have. But do that for your process too. Have checkpoints in your process where you just talk about how it's working for you, where the pain points are, where you start to get stressed, what you find satisfying. Basically get together and talk about your feelings about the process, because that's gonna tell you where the real pain points are. You can also test it if you've got like big enough teams or enough teams. Have different teams try different ways of doing a particular piece of your process and see how they feel about it, see how it works. This also implies that you're measuring something. That's also important. I'm not gonna get into that here because that's a whole separate talk by itself. But try out, do like little spikes for your process and see what happens. If pieces of your process are getting skipped, or pieces of your process are getting emphasized, taking longer than they should, notice that, call it out, figure out why that's happening, talk about it. If everybody is consistently skipping the step in the process where they go check something off in an Excel spreadsheet, not that that's ever been a part of my life, talk about why that's happening. See if that part of the process has value, and if it does, figure out if there's a better way to add that value without that particular piece. If it doesn't have value, then just remove it from your process, and then people won't feel like they're sneaking around, oh, this is so annoying, I'm just gonna skip it and hope nobody notices. That doesn't help anybody. Sometimes it's fun to build for Utopia. Who plays video games in their spare time? And I'm including, Farmville and Cookie Clicker here. I'm not talking about, okay, all right. So I play a lot of video games in my spare time. I like video games. This background is from Destiny, which is a console shooter that I really like. My favorite activities in video games are the ones where you have to work with other people, which frequently means strangers on the internet you've never met before, to do something very hard. And at the highest level of these games, what we call the end game, because you've kind of completed all of the other content in the game and you've just got these challenges left at the end. At the highest level, you're working with 6, 10, 25, whatever, other people to do this really, really hard thing. And this really hard thing demands perfection from every single person in the group. And if one person is not perfect, you have to start over and do it all over again. We'll work on this stuff for hours. No problem. Me and strangers on the internet. Hours and hours trying to get this perfect. When we finally get it perfect, we get in-game rewards because that's how video games work, is they give you rewards. But this sense of satisfaction always overshadows that for me. It's like, man, I was perfect for like 10 minutes. I was perfect. And so is everybody else. And we were communicating perfectly and everything was perfect. And it's a really good feeling. I want Utopia in that instance. I rose to be Utopia in that instance. That was really fun. That was the challenge. This stuff, video games, Sudoku, chess, it's all in pursuit of perfection. And that's really fun to rise to. It's a good time. I like it. It's fun for me. If you're building software, most of the time you're not building for a person who's striving for excellence in using your software. Unless you're building a video game, and then obviously it's a different story. Or if you're using Vim and you're playing Vim Golf. Anybody played Vim Golf? So you try to do like these big operations in as few keystrokes as possible, and that's pretty fun, and that kind of turns Vim into a video game, and that's great. But most of the time, if you're building software, nobody's trying to use your software well. Nobody's trying to do a good job at using your software. They're trying to solve their problem. Your software is a tool. They're trying to solve their problem. And they don't care if they do it right. They just want to solve their problem. And they're not perfect. And they're not trying to be perfect. So there's really no reason to demand perfection from your users. There's no reason to demand perfection from yourself. In a software development process, you're the user of the process. And you're not a perfect person. There's no reason to expect perfection. There's no reason to expect utopia from anyone involved in these processes, anyone using the software, anyone trying to open a door. There's no reason to demand that. So don't. Build in some flexibility. Build in some forgiveness. Build in some empathy. Because the person using your software is probably someone who would leave their stove on overnight. And they didn't mean to, but it's going to happen. So help them finish what they need to finish, and don't make them feel bad for not being good users. And that's all I got. So thank you very much. These are our sponsors.